Hello, hello. Let's see here. Can you all hear me? I just need to rearrange a few things while we wait until 5 past. Let's see, so desktop, what I wanted to do was put that there and then, whoops. Okay, so where's this cut off now? Leave that there. Okay. Well, I guess actually I'm going to put that there. That go over here. That can come over here. Hello, hello everyone. Hello, hello, hello. Tab 9 at Hogs GPU. Well, don't use tab 9. No, it's okay. Okay. Here is the link to the slides while we get ready. Pinned that. That should be good. And then the other thing I think I need to do, yes, that's broken, of course. Let's see here. That look good? No, it's the wrong one. No, that was the right one. What have I done? I got it the wrong way around. Oh no, that's fine. Okay. Sorry, bear with me, everyone. Oh no, that's definitely the wrong one. Okay, Chrome. Okay. Okay. All right, 6 past, we're almost good to go. How do you navigate the slides? Do you mean how do I navigate them or how do you navigate them? I'm not sure what this link actually sort of looks like, to be honest. It should just you don't navigate them. You just follow my, like they'll just follow me when I navigate. I changed classes a while ago, but my Teams group hasn't changed. Yeah. So unfortunately, what I thought would dynamically update people in the Teams doesn't actually do it. So I'm going to make an announcement to the tutors to just do an update to get everyone in the right teams if you're not in the right team. So bear with me on that, Daniel. Yeah, I was misled. Okay. Welcome to lecture 2 for week 1. You'll find out your group organization in your first tutorial. Your first lab. Let's see here, we've got 150 people, much less than yesterday, but it is climbing. So that's good. Now, this is the one I think that you're all excited for, or you all should be excited for, the first lecture on Python, maybe your first introduction to Python altogether, which is super exciting. So, like yesterday, okay, I should firstly say that from as far as I can tell, the GitLab related issues were resolved late last night. So if you generate a new SSH key, delete the old ones that were there, maybe you might need to do this, put a new one up there, and you should be able to clone down the labs and work on them. But if you can't, just use the forum and work on that. Now, the lectures are not where we're going to be solving sort of installation issues. We've got the help sessions, the forum, and the tutorials and labs for that. Just another quick update on that. Don't listen to any lies or slander about the difficulty of languages, Ricardo. Python is an awesome language. I'm really excited to teach it and show you about it for the first time. So let's get straight into it because we don't have that much time. I've pinned the link to the slides if you want to follow along. And let's talk about Python. So what are we going to talk about? Python, we're going to talk about the language itself. We're going to introduce it. Now, most of you came from COMP1531, so we're going to compare Python to C in a lot of these instances because that's what you're most familiar with. We're going to talk about some of the core language features of Python, and then some of the stuff that happens with the Python versions. So what is Python? So Python is a higher level language than something like C, and I'll talk about exactly what that means in a moment, with a rich set of libraries that have common applications, and it's commonly used for building services, utility tools, and it's used a lot in data science. It's the premier language for data science, and I'll talk about why I think that might be as well. And it's a go-to language if you just want to pick up one programming language. It's often the first and only language that certain people learn, not people like you. So you guys are going to be learning many languages throughout your studies and your careers. Your computer scientists, your software engineers, or your engineers in general. But for a lot of people that are just picking up a programming language to do things, it might be a case where they learn Python. Python helps us very rapidly build applications due to the design of the language. You'll start understanding what I mean by that when we start looking at the syntax and getting to play with some of the language features. Running it is very simple. That's because there is no compiler for Python, and we'll talk about how that works as well. It's structured very simply, and because of those reasons, it's useful in data science. So, do you want to quickly type in the chat if this is the first time you're learning a second language? So you've all learned, hopefully, C in COMP1511. Who is this the first time that they're learning a second language? You can just spam like yes or no. Most people, it looks like about 70%, it's the first time you're learning a new language. So I think this is a very, very important moment in your computing career. Something that I believe very firmly is that if, when I'm talking to sometimes students or even people that are in computing, the way that people talk about programming languages is very telling to me. To me, languages are not very important. They are very important, but if you learn the concepts of programming, what you learned in COMP151 and what you learned in C directly applies to what you will learn in Python. The concepts are the same. In fact, really, really under the hood, Python runs as C. Now, you'll never sort of see that or touch that, but that's how sort of married the languages are. The way that you make decisions in terms of what branches of code to run, the way you repeat code, the syntax changes, the concepts don't. So it's a very important exercise, and it's something that once you get practiced with, as long as you're learning a new language in the same paradigm of language, should start getting easier and easier for you to pick up new languages. And that's why the purpose of this course is not to teach Python. The purpose of the course is to teach software engineering, and we'll use Python and we'll help you learn Python. So let's have a look at some of these items in this table. Okay. So, is Python procedural? Yes, it definitely is. So is C. What does procedural mean? It means that you are providing a sequence of instructions to the compiler or to the computer that get run in sequence, and that that applies to both. Java is not procedural because it's a fully object-oriented language. Now, Python is also an object-oriented language, but it can also, it's a bit of both. It can run procedurally. Python is also object-oriented, like I just said. Is Python typed? It can be, and the Python team are really building on the typing features with each version of Python. If you look at C, yes, C is definitely typed. And types are one of the big differences between Python and C, and something we'll talk about as well. Does Python have pointers? In this table it says no, and C is yes. What this is really saying is that you can make pointers in C as a first-class language feature, which is true. In Python, you can't create a variable that is typed as a pointer. However, it's not really true. It's not like the language doesn't have pointers. In many ways, everything in Python is a pointer, but you don't have to deal with them. So that's why the table says no. Is Python compiled? No. So then how the hell do we run Python code? We'll talk about that as well. Let's take a moment to have a look at some of these questions. We have the yes and the no's. Does Bash count as a language? Absolutely. You learned Python before C. There's nothing wrong with that. There are pointers in C++. Yeah, good point. Not sure what that slide is saying there. Okay. What is a paradigm? Good question, actually. So a paradigm is a family of languages written in a certain style, designed to do a certain style. So procedural languages like C, Python, Pascal, if you've ever heard of that language, are procedural. You've probably heard of functional languages. That's a different paradigm of languages. They run with a different base. It's a different base concept underneath with how the language actually works. If you've forgotten most things about coding, that's okay. You'll learn it really quickly. Okay. Whoops. So we have another summary here. I've sort of already gone over this. Python doesn't have types. Well, it does have types, but it's not exposed to you. It does have some object-oriented concepts, so this is not an object-oriented course. You don't deal with pointers, absolutely. It's a higher level language. It's more abstract. It's one step away from the CPU. That makes sense. And we don't have a compilation step. So let's look at some code. Talking is boring. All right, so let's look at the C program for this. And what I was actually thinking of doing is, oh, that's a bit better. Let's get this running in a program. So one second here. Okay. Actually, what I'll do is this. Oh, I wanted to delete that. All right, sorry about that. Let's move this over here. Okay. So we've got some code here. Let me make this a bit bigger. I've got my terminal down here. What I've got here is a Python file. Now, first, before we look at this, let's quickly look at the C code that we've sort of adapted. So let's run through this C code line by line. So we've got a function called add two numbers, right? It accepts two parameters, and they're both typed as integers, right? So you accept the parameter 1 and the parameter 2. Then we're declaring a new integer called 3. We're adding up 1 and 2. Then we're creating a new memory allocation, which looks like it's going to be an integer array of size 3, right? We've all covered malloc in C before. ARR is a pointer with a memory allocation of the size of an integer multiplied by 3 because we have 3 numbers that we want to put in there. Then we're allocating each index of the array to each one of those. So the 2 parameters that were passed in, which are integers, and then the third variable that we calculated as 1 plus 2, and then we return that array. So 8 lines of code to define this function that creates a third variable, creates an array, and allocates all those values to each index in the array. Now let's look at the same code in Python. Go to VS Code. Let me make this a bit bigger. I might even just hide this. Does that look good to you guys? Python is why has Python become so popular and so powerful and used so much in so many different fields? It's because it's so simple. It's so simple to write. Yeah, I don't know. That C code doesn't look 100% correct. Just it's just the idea of it. That should probably be returning a pointer. Right. Python is very expressive. So let's look at the definition. How do we define a function in Python? Well, we use the def keyword, which stands for define. Notice we don't provide the return type of this function. What type does this function return? We don't know yet. All we know is that I have a function named add two numbers. Okay, it accepts 2 parameters. What types are those parameters? I don't know yet. Neither does the Python language. And then I have, okay, this colon represents what follows here is the function. This is similar to the curly brace in C. Now, how does Python know which of these lines are part of the function and which of these lines are not part of the function? Like 4 equals 4. Can someone answer in the chat? How does, you know, in C, we would have some braces here, something like this, right? We don't have that in Python. So how does it know which lines are part of the function and which lines are not? Jaden, you're the first one I saw. It's the indentation. Absolutely. The indentation here, see, I've got 4 spaces here. That's what I've set up as my default indentation for Python, is actually interpreted as part of the language and is telling the Python interpreter what should be happening where, what block of code is running where, what scope do these lines contribute to. So that means if I run my code like this, this is not equivalent. This is very different from C. In C, you know, if you've got a bracket here, and you were probably taught this when you learnt C, you know, the formatting is just for us. That's what we teach in C, right? The formatting is just for humans so that it's clear what's happening where, but this is equivalent to this, not in Python. The indentation matters in Python. The formatting matters. A lot of you will run into issues, and it may be because of how you formatted your code. Okay, that's the first line. So that's the main difference between C and Python. Let's look at the second line. I'm creating a variable 3 here. I did not have to tell Python what type that variable was. We'll talk about types in a second. I just said, hey, I want a new variable of type 3. And I want to assign that the value of 1 plus 2. You can see that's a very similar line to C, right? Let me just That's the C equivalent here. It's a very similar line, we just don't have the type, right? Here's the crazy line, and here's why Python is so cool. This is saying, hey, I want to return, okay, I want to return what follows. What follows is an expression. What this is saying is, I want you to take my three variables, 1, 2, and 3, and wrap them as an array. They're not really called arrays in Python, but wrap it as an array and return the array. So in this one swoop, we're returning what in Python term is called a list, containing three values, 1, 2, and 3. Is this a list of integers? Yes, but no. Yes, because 1, 2, and 3 probably will be numbers. Actually, we don't actually know that because we haven't called this function. But it doesn't really care. It's creating a list of some elements, and the elements that I'm putting in it are the variables 1, 2, and 3. And that's it. We don't need to malloc. We don't need to define the size of the list. We don't need to individually set the indexes of the list. The language is doing the heavy lifting for us. And you can start to see why, if you're either a lazy programmer, or you're a time-constrained programmer, or you're someone who doesn't really understand programming, why Python is so alluring, right? Because it's just very logical. Why are we returning the list in this example? Because we were converting the Python, this sort of Python code that was returning the list. So this is just a demonstration. Let's run this. How do we run this? Good question. No one asked, but good question. And then you're going to see even more differences between Python and C. So cool. So in my setup, and again, the lectures are not setup tutorials or setup courses. I've already got my Python 3 here configured. If I just run Python 3, whoops, don't worry about that. If I just run Python 3, it does this weird thing where it opens what's called an interpreter. We'll talk about that another time, but that's how you can see Python is installed with version 3.7. In this course, we're having everyone use version 3.7. How do I run this program file? Well, I'm in a directory with this file, program.py. I run Python 3, program.py, and then that's it. I just hit enter. Nothing happened. Why did nothing happen? We didn't actually call this function. We defined a function. We didn't do anything with it. So that's why nothing happened. But it's successfully interpreted and ran this file. Now you'll notice I didn't compile anything. I didn't build anything. What's going on with that? In a typical language, in C, which is what you're used to, you have some source code, the C file. You compile that down to machine code and you execute that machine code. In Python, it works completely different. You run the Python 3 program, which is an interpreter. It runs through your source code that you've provided it line by line and executes it, interprets it, and executes it sort of on the fly. Let's actually run this code. We need to call add two numbers. We need to give it some parameters. And I need to give it some variables here. Let's just keep it simple, right? Let's give it the integer 1 and the integer 2. I don't know why I highlighted this backwards. Do I need to add a semicolon here? Can I move my cam to the... Oh, absolutely. Thank you very much. I can even make it a little bit bigger. Good catch. Thank you. No, Python does not use semicolons to separate instructions or expressions. We don't need to do that. So this will then call that function, passing those two values, and we'll see what happens. So I'm just going to hit up, hit run. Oh, okay, and nothing happened again, of course. Why not? This returned the value and it didn't print it. I mean, nothing's changed there. C would do the same thing here. So why don't we then, so what we could do, so in C, let's see, you use printf, right? Use printf in C. You would have given it, maybe you could just give it the function call, tell it I want to print an integer, an array of integers, blah, blah, blah. You have to stuff around with all of that. In Python, going on with the theme, it does all of that for us. So I can just call the print function. Okay, print is a function that can accept a wide range of things. In this case, let's see what happens if I just pass it an array. There we go. Let me just run that again so it's clear. There's the array with the values 1, 2, and 3. Now let me just catch up on the chat a little bit. Excuse me. I moved my camera. Don't use version 3.8.1. You have to use version 3.7.x. You can use any version 3.7. No semicolons. Everyone's screaming. You can. Awesome. Can we call a function before we define it in Python? Let's try it. Let's move this to before the function call. No, we can't. Add two numbers is not defined at the point that we were calling it here. Why does this work? Why does this not work, I should say? When we call the Python 3 interpreter, it runs through line by line. Okay, so it comes to line 1. Okay, I'm calling print. What do I need to print? It jumps in the brackets. I need to print add two numbers. It has not come across add two numbers yet, so it can't call the function. So it has to be done like this. Unlike C, you can't forward declare functions that I know of. Maybe there is a way to do it, but I don't think you can. No. I'm going to say no. Maybe someone can double check. You can't forward declare functions. So you need to just restructure the file so that it's already been interpreted by the Python interpreter. The reason for that is a Python interpreter happens in one swoop. So if it hasn't found it, it's not going to go through again and find it. The reason why we can do it in C with forward declarations is because it has that compilation and linking step, so we can learn that it appears later, or it can be told that it appears later, and then when it's compiled, it already knows how to find it. Okay. Magic, you ask an excellent question. You guys are asking very good questions. Is the comma part of the list as a string? What happens if you don't want the brackets or the comma? What we're talking about here is I did not tell my print function that I wanted a bracket here. That's absolutely true. So how did it know to put it there? And why did it put it there? Well, it's trying to be helpful. I've passed in print an array and it's trying to decide, okay, well, the best way I think we can represent an array is to use that bracket there to represent that. If I don't want that, I need to build a string myself that represents how I want it to be printed. And so you can imagine that you could loop through the array, printing out each number with whatever separators you want to, for example. Here's how I think about the core difference between something like C and something like Python. C is a very powerful language, a very fast language that leaves the decisions up to the programmer. It makes no assumptions. It does everything as fast as it can, as low level as it can, and it's as explicit as possible. If you want to define an array, you need to tell it how many bits that array should be. If you want to redefine it, you need to reallocate a bigger piece of memory. Python is a different way of thinking. It's all about making some assumptions for the programmer in order to make the programmer's life as simple as possible. So if I just pass it an array, it's not going to say, hey, I don't know exactly how you want this string to be printed. It's going to say, I'm just going to assume that this is a reasonable way of representing it. If you take that frame of mind of thinking and add it to everything that you do in Python, you can start to understand how it all adds up, and you get with a very freeing language that makes you very productive. Okay. Yeah, that's a good line. Arian. How can I reference this array without giving it a name? Oh, good question. You would need to give it a name. So this is a good point. I never actually defined a variable that was this array. So I could just say though that array is equal to that, right? And then I could print the array. If I remove this print, we're going to see the same output. Oh, I need to call it. I just don't want to call print. Oops. There you go. Let's see here. Oh, I'm still confused why we can't use the latest version. Yeah, I didn't really explain it. So, like all languages, but Python in particular, the language evolves over time. Different features are added and taken away, but that's not really the reason why we lock it down to 3.7. The reason we lock it down to 3.7 is because for all of the labs, some of the labs and the project use some libraries, in fact, many libraries. And these libraries, we've configured them in a way to work with a specific version of Python. That was the version that we built the project with the set of requirements locked down. If you were to use your own version, a different version of Python, most of the time you'd be able to make it work. But by default, it wouldn't just run. And so we're just standardizing it across the course so that when we give you the project at the end of the week, when we give you the spec for the first iteration of the project, that you are able to run the project. So it's because of the libraries that we're using, and as the library versions change, they sometimes depend on a newer version of Python or an older version, etc. So we need to specify that. But if you're just running Python yourself, you can use whatever version you like. I might have pressed tab a bit too early. Sorry about that. I don't know what that's referring to. It's because of the requirements for the text. Yeah, that's right. The requirements specify the version of the libraries that we use in some of the labs and in the project. So it's not because we're being arbitrarily, constrained. It's because it just wouldn't work. But 3.7 is a relatively modern version of Python, so don't stress about that. Now, how we change the version, that's a whole different topic that we'll talk about, I think, maybe next week. But if you're using VLab, you already have 3.7 installed. Okay. I spoke roughly about some of the differences in how Python runs compared to C. With C, you have some C files, you compile them to machine code, you run that machine code, which contains the instructions for the CPU, and that generates your output and runs the program. With Python, the Python program compiles and runs on the fly and generates the output. Now, because these are similar languages in many ways, and you already know C, we're going to be covering Python very quickly. You're going to learn it very quickly. And we're just mostly going to be covering some of the differences between the two languages. So don't worry if you're starting to feel like you don't understand Python very well. With time, you'll naturally just start picking it up. It's a very simple language to learn. You'll have a lot of fun learning Python. You don't need to know everything about Python. I don't know everything about Python. No one person knows everything about anything, really. So don't worry about that there. There's a link there for some more information. Python does not have a .o file, no, because it doesn't have a linking step. Do local variables get erased from the stack when functions return like in C? Yes, absolutely. Okay. I covered this. All right, let's do this. Let's get this file up here. Let's get back to code, and let's start having a look. I should ask, by the way, do you guys prefer black theme in VS Code or white? I can actually, you know what? Okay, everyone is saying dark. Okay, I'm not even going to do the poll. Okay, all right, I get the idea. Alrighty. Okay, okay. You guys are going nuts. That was a dumb question. And you know, the other thing that I'm thinking, oops. Is that this might be, I can just get rid of my little mug for a second. This might be a little better. Dark, 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 dark. Okay. Let's run through some Python here. What's happening on line 1? I'm defining a variable called name and I'm assigning it the string giraffe. Okay, that sort of makes sense. I still haven't spoken about why Python doesn't have types. There's a few ways we can go about explaining how Python works and how it's getting around this. Many of you have heard, okay, Python doesn't have types. Who's heard Python doesn't have types? Python's untyped, Python doesn't have types. You're all still going on about the dark and the light theme. Let's move on. Who's heard that statement? You have, well, I mean, you're right, we lied to you as well. We said in the table that it doesn't have types. Python does have types. Python does have types. Don't be lied to. What it doesn't have is the need for us as the programmer to specify the types. Okay, what does that mean? Python is smart enough to know that, okay, what you've given me here is a string. So what type should name be? It should be a container for a string. It just knows how to do that. The reason it can do this is because every variable in Python, so this name variable in Python, is not actually a string type natively in the memory. It is a pointer to an object that it then can place the string in. That's the sequence of bits that makes up the string giraffe. And so it's able to dynamically sort of hot swap what's in that variable. Line 2, same thing. I make a second variable called age, and I'm assigning it the integer 18. Python knows, okay, if I've got some sequence of integers without a full stop, without a period, that's an integer. It knows age is an integer. It also knows if I get a sequence of integers with a period at some point in the sequence, before the end of the expression, that's a floating point or of some sort. And so height is a floating point. The very cool thing about Python, so let's actually just comment that out. So Python uses the hash symbol for commenting out lines. Let's print name. Let's print age. Okay, name is giraffe, age is 18. That all makes a lot of sense. Here's the really cool thing though. I can then say name is equal to, in fact, I can just say name is equal to age here. Now, name was defined, and I told you it was assigned the value giraffe, which means it interpreted the type of name as a string. But then I assigned name to be the value of age, which is an integer 18. Well, how is that going to work? It just works. Name, which I printed here, is that value 18. Again, it was smart enough to say, okay, well, name is no longer a string. I assigned name the value of age. Age is an integer. Well, now it's an integer. So this is why people say, oh, it doesn't have types. It doesn't have types. It just works. Under the hood, it does have types. It's just doing all the heavy lifting for us and inferring what that type is. In fact, how can I prove that? If I print the type of name, I think that's the syntax for it, hopefully. Okay, there we go. Name is an integer. There you go. There's hard proof that Python has types. It knew that name was an integer. So let me catch up on chat. How did I highlight all the strings? Yeah, I'm using command /, which is the block command. You just select and then hit command /. Yeah, it's just telling the type without defining it. Exactly right. Okay. Okay. Let's keep going. Let's get rid of all that. Let's look at some expressions. All right, yeah, this is fine. Defining a variable called num1, and what is this operator? This is, I think, the exponent operator. So if we just run this now, oh, okay, we're not printing it again. Keep forgetting that. What was it called? Num1. I run that. It's 27, yeah, because 3 to the power of 3 is 27. There's no way to do something like that in C, is there? Once again, it's the same sort of idea. Python, the developers of Python are trying to be helpful and give you lots of shortcuts to doing things so you can think about your problem and not about your syntax. I can't even remember what this divide does. Someone in the chat want to let me know? So see, it's a scam. Yeah, it's not a scam. Yeah, that is what it's doing. You're right. So it's doing a division, but it's casting it to an integer. So if you remember, I think if we just do a divide. Okay, yeah, perfect. If we just do a single divide, and this is the same in C, right? I know a lot of you would have been tripped up by this at some point. You divide an integer by an integer, you get a float because C can't, even Python, can't, well, if you divide two numbers, you might get a floating point, so you have to get a floating point out. But sometimes we want an integer. So in C, you would have to then cast that back to an integer. In Python, they just have a different operator for it. You run that and you get an integer out. Let's comment all of this out. Let's go here. This is designed to run with these defined, I think, and height. Okay. So just to clarify here, we've got age is 18. I'll put that back as name is giraffe. Sorry. And then height is this number. Okay, let's look at some of the ways that we can print. Printing in Python is so cool. It really makes our lives easier. Here we're just printing a string. That should all make a lot of sense to you. We don't need to do string formats by default, so that just prints that out. That should be pretty straightforward. Here we have one common way of printing some concatenation of strings. So we can print the variable name, which is giraffe. Add on to that string a string literal, which is a comma and then a space. So that's that comma and that space here. Then add age, which is an integer converted to a string. Then the same thing with the comma, the same thing with the height. Why do we need to do that? If Python isn't able to print out an integer, it does need to know how to convert that to a string. Now, there's some other ways we can do that though. This is a really cool way of doing it here. You can just give it all your variables. Then we do something crazy here that I'm sure you've never seen. And we get the exact same value printed. How does this work? Well, what this is called a named parameter or a named argument in Python, because functions don't have types and the order for print can change. Basically, I'm naming the parameter so that the print function knows that this isn't just a string I want printed, but it's the actual assignment to that parameter. So what we're saying here is that I want to print out these three variables, but I want them separated by this character. And so we get the exact same output. Finally, the third way we have that we can do this is called a formatted string print or a formatted string output. So we have this F here. I hope you guys can see this okay. We have this F here, and what that says is that what follows, I want built from, I want to build a string, and I want these variables, I don't want it, so, okay. The curly brackets say what happens between me, okay? I expect to be a variable that would be computed and displayed as a string. So we get the string built here. So F strings are a really nice way of building a string and building it out in the way that we want to get it printed. I already spoke about the type stuff. Let's jump to the last example and then look at some questions. It needs number 1 and number 2 defined. Okay, so here we have those two variables. Let's run this. Some printing mixed. So here we have a string, literal, as well as an F string formatted in there. And that's just two examples of that. That's pretty straightforward, actually. So you get that printed out. Okay, let me catch up on chat. There's been a lot of questions, I think. Where was I up to? Oh, that's a really good question, Keenan. Great question. Okay. In C, once again, when we printed with printf, we would need to do something like printf, some string, \n. You would have all seen that many times, right? So that we had a new line printed. We don't have that in, let me do this again. If I just run this, hopefully nothing else. Yeah, okay, no, I get some string printed out, but I am getting a new line character printed out, but I didn't give it a new line character. Once again, this is an example where Python is trying to be helpful, and it's saying, I'm assuming most of the time when you print, you want the new line being printed. But what if you don't? Well, of course, we can control everything. There is another named variable called end for print, and the string that you provided is what gets printed at the end of the string. So let's clear this and run this. There we go. Or you can see here that, okay, to demonstrate that a bit better. It's not printing the new line between them. If I did not have this new line, this end parameter, or I gave the end parameter as the new line carriage, it would print how we expect it to print. Same if I just delete that. Yeah, I do have font linkages, Hamish. That's what's happening there. Don't worry about that. So Daniel asks, does the separate aspect remove the need to convert them to strings? So I think what you're talking about is like here. So it removes the need for you to convert them to strings, but it is still going to be converting them to strings at some point, because what gets written to the terminal must be a string. which print function is preferred? There is no answer to that. It's whatever gets the job done, really. What is the F meaning in the brackets? So you're talking about here. So this is literally called an F string or a formatted string. Now, interestingly, actually, that it's not anything to do with printing. So I can make my string here be assigned to this F string, and I can just print, oh, I shouldn't call it string, I guess. And I can print my val as long as that name is declared. I can't remember. Yeah, it is. Yep. And we get that same string printed out. So we can actually, it's an expression that says execute this and create a string with these values put in this format. That's why it's called a formatted string. This is sometimes called string interpolation in other languages. I can talk about my font and stuff at the end. I'm still confused about what F does. Okay, you shouldn't be confused. Why is C called print? Yeah, it's okay to be confused, but why does C use printf? It's print formatted. We give it a string, and then we give it the positions that we want the variables, and then at the end we give it the variables, right? Blah, 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 blah. It's the exact same thing, except you don't have to put the position and then the values at the end. You can just do it inline. This is like C's printf. But what if that sum string is longer than 80 columns and has to be split in two? How is that supposed to be written? What if sum string, so just down here, this one here, I mean, it will just wrap in the terminal. It's just going to print out that string. But I might not have understood the core of your question there. Yeah. So is name the same thing like %D, %I, %S in C? Absolutely. You just don't need to put the position and the types. Yeah, printf is not print function, it's print format. Oh, okay. So for multi-line strings, we can also do that. There's a few things we can do with these. These are pretty cool as well. You can give 3 quotes as... Sorry, this is going to be a bit hard to see here. You can give 3 quotes. I can say, hi, my name is... This is really cool, actually. Jake Renzella. I am happy to be here. And you can see, if you give it 3 quotes, it says, I'm going to print everything that follows, including the new line characters. So, I mean, that's a really nice way you can see that you could structure some multi-line printing. Who's lying to you, Daniel? Okay. Wow, it's already 3 o'clock. What did I not get through here? Strings, I think we've spoken about strings many times. We've just spoken about strings. Now there's a note here. Python strings are immutable. So I'm not going to spend too long on this because it's not really that important, but what does that mean? Immutable means a variable can't change. But as we saw, I can reassign a string. So this would run how we expect it to. Whoops, you just got to make sure you're not indented. I clear this, I run this, these strings, this sentence clearly got reassigned at this point. The reason that Python you can't see my code. What am I doing? Sorry, I just ran that code that you were just looking at, and you can see that this string here, sentence, definitely got reassigned. My name is Pikachu. But The reason why it's still immutable is because it basically had to make a new string and reassign that in that position. It just does it for us. But don't worry about too much. And here's another really cool language feature of Python. Here's a string called hi. I can say I want to print that times 10. What does that do? It prints it out 10 times. Pretty cool. Why would you ever want to do that? I have no idea. Okay, what does plus equal to mean? That means, you should know that from C, surely, but that means take whatever value is in the variable and then add this after it and then assign it back. So if you had, num equals 1, num is plus equal to 1, what is num now going to be equal to? If you said 2, you're correct. Will the exponent on line 7 work as well? Not sure what you mean. Do you mean if this is like this? I don't know what that would do. Is that going to do it 20? Is that going to do it? Let me change the number, actually. No, I don't know what this will do. It might not just work. Yeah, that doesn't do anything. Okay. I can't believe that's already 3 o'clock. Let me just quickly go back. I think we spoke about strings enough, to be honest. We haven't spoken about slicing. That's okay. It's a bit advanced for now. We haven't spoken about control structures either. But that's okay. We'll be doing all of this in the next lecture. In fact, I can just keep going. Control structures are probably, yeah, I skipped lists as well. That's okay. I can keep going and make the first half lecture a bit longer. I think the second lecture is a lot smaller. When I say second lecture, I just mean the 3 o'clock to 4 o'clock segment. Now, a couple of you have asked about the PDF slides. They will 100% be made available very soon. The reason I can't generate them yet is because, so these are Hayden's slides from last term, and you need to have a paid slides account to generate the PDFs. So I just need to either get him to do it or to figure out an alternative to that. So bear with me. But like I said, if I just get the desktop up, if you go to WebCMS, you go to the lectures, you can click, Python here, and you can just get the slides. Now they're not PDFs, but you still do have them in the meantime, but I will still generate them. The other thing worth talking about actually quickly, at the top of that lectures page, all the code in the lectures is here. So you can go to 1.3, which is this lecture, and you can see all that code that I've been running is here. Okay, let's go back to the keynote and keep talking about some Python stuff. Does everyone want maybe a 5-minute water break or something like that? Or are you guys good to keep going? Yes, please? No? Sure? What I'll do is I'll talk for 5 minutes about non-content related stuff if you want. Just keep going. Yeah, I'll talk 5. I'll still stay here. I'll talk about 1 hour break. I'll talk about non-content related stuff, and then we'll keep going. But 3:05, so you got 4 minutes. Talk about coffee. What does it mean by int object not callable? I don't know what you're referring to there, Felix. Talk about a recent project. I can do that. I can talk about my biggest project. Has everyone seen the formative system yet that we asked you to use to submit your lab reflection? Oscar, that question, you got to tell me. I'm new to the campus, and so far the coffee has been average. So, in the course outline, we do mention this, and your tutors and lab will remind you. But we have a sort of reflection / feedback activity. So there's no extra work around what you have to do with it. But we're asking you to use this formative system to submit some lab work that you did that week and then talk to your tutor about it. And this system actually is, you can see me there, the one that I build the most. I work on this platform. So yeah, so this is the system that we're asking you to use to show your lab code to your tutors. Yes, it contributes to mark, but you don't have to do any extra work for it. It's all in the course outline. But yeah, we'll give you, don't worry, you haven't missed anything yet. We'll give you harder instructions on what we want you to do and stuff here. There you go. There's a lab set. So the details around what we're using it for is here. The point isn't to talk about the assessment itself. You don't actually have to do any extra work for it. What I was trying to do is come up with a way that would get you to get some more personalized sort of check-in feedback. You only have to do it a few times in the term. So we haven't really revealed the details yet. But someone asked about personal projects. So, I mean, you can see, for example, in the web repository. So this is the front end for the repository. This is all an open source project, so anyone can view this code. I think is it under Insights. You can see contributors. You can see how many lines of code I've written for this project. It's about 357,000 lines of code since 2016 or so that I've been working on it. So that's my biggest open source personal project that I work on. Okay, the pipelines. Okay. The pipelines were broken and they're now fixed. So if I come find a random, who's done, someone give me their name that's done a lab. Okay, Ben's done one. Ben McMillan, here we go. Let's see, it looks like you've done integers. Okay, you can say your pipeline passed. Congratulations, Ben. That means the work you did for this lab is complete. How does the pipeline work? What is the pipeline all about? When you push code to your GitLab repository, we automatically look at the work that you did and we basically run some tests on it. And if the tests pass, we say that the pipeline passed. So this is how we do our auto marking for your weekly labs. And we run all the tests on it. If you push and it fails, just like it looks like it happened with this push, not to put you on the spot, Ben. Okay, that was the sanity thing. I think that was our problem. But you can see 5 hours ago. So it looks like straight after it finished. Yeah, the lab worked. So all you do is git push and then it's automatically done. That's it. You don't make your own pipeline tests, Ricardo. You can just make your tests locally. We're talking about testing in the second half of the lecture. I mean, you could, if you had your own instance of GitLab, you could build up your own pipelines, but the pipelines are not something that are in the scope of this course. How do you access formative? You just go to formative.csc.unsw. You just go here. You should already be enrolled. You click Software Engineering Fundamentals, and then you just go to the week 1 lab and upload some code. But we'll give you more instructions on that soon. Cafe Positano on Maruba Road has great coffee. Ooh, that sounds good. Thank you, Oscar. Yeah, you can just, Sienna, you can just keep doing it until you pass. We'll talk more about that as well. But basically, you can also test it before you push with the local test files if they exist. Otherwise, you can just push them. Do we have to bring our own laptops? You don't have to. We give you computers in the lab, but I recommend bringing your own computer if you have one. Okay, we don't have enough time to talk about all of this stuff. But what we can do is have an informal, like an hour, unscheduled, sort of mini lecture where we can talk about unrelated stuff. Okay. Let's go back to the keynote. Now, here we go. Let's see. Okay, let's talk about lists and tuples because this is important. Let's clear that. Okay. We already sort of touched on lists a little bit. Lists are the native sort of thing like arrays in C, but they work quite differently. In fact, lists are not really like arrays. Lists are like vectors from C++, if anyone's touched that. What's the difference between a list and an array? While I'm doing this, if you guys want to type some answers to the question, if you know, you can feel free to do that. List versus array. They are both sequences or collections of like data. They both are contiguous pieces of memory. Hopefully you all know what contiguous means from COMP1531. You should all know. They both have indexes, or indices, I guess. What are the differences? So the main difference between a list and an array is that lists do not need to have the size predefined. So if you can see, and the size of the list is dynamic. So here we have, in fact, I probably should have left that for you. Size can be changed. Whoops. They are dynamic. I can add without, malloc manually. So let's have a look at this in an example. Here we have an array, or we have a list, technically not an array, although under the hood they are actually arrays. Oh, you can't see what I'm typing. Ah, sorry. I was typing all these nice notes for you. That's okay, you didn't miss much. You can read the notes now. Sorry. Let's run through it quickly. They're both collections of like data. They both use a contiguous piece of memory. They both have indices. So this is the other point. Don't confuse lists in Python with linked lists from COMP1511. They're completely different. The differences. Size can be changed in lists. Well, in fact, another difference is that the lists know their own size, and they can be dynamic. So here's a list. Names is equal to Hayden, Jake, Nick, and Emily. Oops. Oh, if I hit Shift Enter, it's running it. That's pretty cool. Okay. I can do names. I think what I actually do is size of names. No, never mind. It's len, isn't it? Whoops. What is the length of names? Go away. I don't know what just happened then. What's happened? Oh, some of the code here hasn't copied over properly. That's okay. We don't really care about that yet. Let's just do it like this. Okay. I gotta print it. Of course. You can see here that in the list itself, the object knows that its size is 4. Why is its length 4? It's got 4 elements in the array. Yeah, this code is all in lecture code 1.3. Yeah, absolutely. So that's one difference. It knows its own size. Why is that important? It means that I can do things like this. Names.append. Let's see someone's name here. Felix, you're the last name there. Okay, the size was 4. Now the size is 5. In one line, I added a new value to the end of my list, and the size automatically updated. Okay, just like C, our lists are index-based, so I can go names 2. Which name is names 2 going to print? If you answered Nick, you are correct. Why? 0, 1, 2. That should be no surprise to anyone. What else can we do here? We can reassign specific name sort of values. So we can say names 2 is equal to Rani, let's say. And now when I print it out, it's going to say Rani. Whoops, what did I just do? Okay. All right. That's all of that stuff covered. What else do we have? Okay, tuples. Let me read arrays here. Sorry, arrays. Let me read the questions. Okay, yeah, sorry about my ligatures are causing confusion. Font ligatures are when you have like a combination of characters that makes that like my font is just joining the characters together. You don't have to worry about it. These are just equal signs. It's just trying to make it look a bit nicer. Arrays only all of the same type. Great question. The answer is yes and no. So I can say that element 2 here is just going to be the integer 13. And when I print that, it will print out... Whoops. Okay, sorry, I shouldn't have run this. It will print out 13. Whoa. Oh, sorry. Okay, hold on. They're the sizes. I confused myself. If I print just names, here we go. We can see it's Hayden, Jake, 13, Emily, Felix. So I can put an integer in, I can change the type of the elements in the array. Sort of. Functionally, as a programmer, yes, I can. Under the hood, why is this possible? I said earlier in the lecture, all variables in Python are objects. What does that mean? That means all variables in Python are pointers. What does that mean? This is really just an array of pointers under the hood. But in terms of what we are able to do, we can change the types dynamically in the array. This is something very different to something like C. You can't do anything like this in C. Fundamentally under the hood, the principles that you learned in C are actually still applying here. It's just that basically what we're storing is not just the string Hayden and then the string Jake, it's a pointer to a piece of memory that has the string Hayden and a pointer to a piece of memory that has the number 13, for example. All right. Now let's look at the tuples code. Let's get rid of this. Now what are tuples? Tuples are a new concept as well in Python. A tuple is a pair of values. Okay, so for some reason here, I think this is some brackets missing. And that's probably just like, you're not allowed to do that. All right, so what's the issue here? Oh, it's saying, okay, yeah. So let's ignore these two for now. So here is a tuple. Animals is a tuple. A tuple is a collection of values, sort of like an array, but they can't be changed, basically. The whole value animals becomes one sort of hard-coded immutable value, which is the tuple giraffe, turtle, and elephant. So I can print out the tuple, giraffe, turtle, and elephant. I can print out a specific index, so I can print out giraffe, but I can't change individual elements of my tuple. And you can see that here when I try and run this, it's going to say the tuple does not support item assignment. The reason why this exists at all is a performance reason. Because arrays are just storing pointers and that they can be dynamically changed, it means that they need to have a lot of memory allocation and room left in case things do change. Because we know the size and the elements that are going into this tuple, some performance enhancements can be made by the underlying code that we don't have to worry about. So it's an option in certain circumstances where you want a collection of values and you know that they won't change. Okay, there is so many questions being asked. Let's see. What does length do? Length is a function that accepts a list of some sort and gives you the length of it. Pretty crazy. Blah, blah, blah. Some talk about JavaScript, that's fine. Yeah. They're like constant size lists. That's a good way of putting it for tuples. Is a tuple kind of like a struct? No, because there's no key value. Why would you choose a tuple over list? There are some performance reasons why you would need to. Yeah. So in terms of actually making a tuple, the only difference here is the brackets that you use to define it. Good catch. Is the maximum value of a tuple the same as an array? I don't know if there's any restrictions on the maximum size of a tuple, so I'm going to assume it's the same. The main difference is that you can't change the size of it. And similarly, I don't think you can append. Yeah, you can't. I'm not an animal though, but yeah, you can't append to a tuple. It needs to be a constant size. Think of it as it is like a struct in terms of it's like trying to create because it knows the maximum size of the tuple and it knows that the tuple can never be extended or that the values can't be changed. It knows exactly how much memory needs to be allocated to create that tuple. And what that means is it doesn't need to allocate any extra. So the way Python works under the hood is that it's so flexible because basically it's allocating more memory than it needs so that if I change things, it's got room to fit those changes. By making a tuple and it's so static, it doesn't need to have that ability to change its sizes, so it can use much less memory and be more performant. So you can't append and remove items for a tuple, no. You can convert a tuple to a list and make some changes and turn it back into a tuple though, good point. What does line 29 and 30 do? Good point here. This is just nothing new, a combination of what we're seeing before. It's printing a string using the f strings that we spoke about. It's dynamically inserting this tuple into the string and expanding it. So it gets the elements from the tuple and it prints it. Now, just like with the lists, it used the square brackets. For tuple, it's using the normal brackets. So it's just printing out the content. Okay, and it's using a string format. Yeah, so I can just put like, hey, my animals in my farm are, the animals. Okay, that's all for lists and tuples at this stage. Let's go back to the keynote. Slicing, okay. I'm gonna skip this slide. You can go to it in the lecture and look at it. Just because we don't really have the time to talk about it. Slicing is a way that I can say if I've got a list of A, B, C, D, and E, how do I say, well, I just want to get the first, up from the first to the third element. Slicing is always, we can do that. So from 0 to 3, that's going to get A, B, and C. But I'm not going to spend the time to run it. If you don't use the F, that's fine. You just won't be able to format the code. So this is going to print out. It's not going to understand that animals is a variable and we want to turn that variable into a string. It just prints out the string literal that we passed it. That's what the F does, right? But we can just print out animals. Whoops. Just like any other value of variable in Python. Okay, we need to move on. Control structure, this whole lecture is going to be spent on Python, it looks like. All right. We don't need to spend too long on this, I think. In C, you can have if x is equal to 3, do something. The structure is very similar in Python. You don't need the normal brackets here. So if number is greater than 10, we have an indentation because that's how we control our blocks, and we have our value. One difference in C, you use else if, right? In Python, you can join them, so it's just elif. Is the stream still going? Because no comments are coming in. That's concerning. And then you have else, just the same. You use the colon. Use the colon to define that. You use the size, the indentation to control what happens where. So nothing crazy with that. Okay, while loops. While loops are, again, very similar. If this would be C, and you'd have a bracket here, right? In Python, it's pretty much like this. While I is less than 5, I is initially assigned to 0. We get, let's comment that out for now. We get hello there printed, 1, 2, 3, 4, 5 times. Again, nothing too crazy there. Okay, something really cool about C. This is exactly equivalent to this block here. What does range do? Well, range is creating a range object. You pass it an upper value here, 5, and it's basically going to generate the values up until that range, so 0, 1, 2, 3, 4. When I run this, you can see we get the exact same output. But what it means is we didn't need to declare this I value. We didn't need to do this check explicitly, and we didn't need to increment that I. It knows that, basically, I think, here's another way of explaining this. Let me copy all this. This is also going to print it 5 times, right? And this is the for in is a structure of Python, and it basically, it makes a lot of sense, right? Like it just goes for I is going to be assigned 0, then 1, then 2, then 3, then 4. So I can print I here as well. Because it is going to be assigning I up into that. Now, what if I wanted to loop through 100 of these? I don't want to sit here for an hour going like 5, 6, 7, blah, 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 blah. That would suck. But I can just do here like 100. It's pretty cool. And we get 100 iterations. Range will always start at 0 unless I give it the minimum. Whoops. And you can see it starts at 50. How cool is that? I hope you're getting the idea here that Python's all about giving us flexibility, giving us options to do what we want really quickly. Can the minimum be a negative number? Absolutely. This is going to loop from negative 50 to 100. It's Python. We can do whatever we want. You can specify the increment. I mean, you can do, how do you do that? Now I can't remember actually. Oh, it's step. You might be right. No, it's not step. Yeah, so you just go range and increment. Yeah, so it's a placement. Yeah, you're right. So it's just the third parameter that we pass it. So I can say I want it to go up in 2. Now this is something that you can imagine. There we go. Now we're counting up by 2 each time we loop. And we started from -50. Yeah, thanks for the catch. So it's start and step. I mean, you can imagine as well, we can go from 100 to 0, stepping by -2. Now we're counting down. You can see how quickly I can really make these dynamic loops do exactly what I want. Well, I'm out of water. That was a waste of time. Okay. I know we're really running through these quite quickly. We spoke about functions a little bit. I'm not really going to go into that. Okay, dictionaries. I don't know how Hayden got through these slides in an hour last year. Whoops. Dictionaries are very, very important. Let's talk about dictionaries. Someone asked me before about, is this a struct? Dictionaries in Python are the closest things to structs from C. Okay, what is a dictionary? It is a variable just like any other variable, and we're using the curly braces to define it. Then it is just a sequence of key value pairs. In this case, the key is a string called named, the value is a string called Emily. The key is a string called score, the value is integer 99, rank 1. If I print that out, oh my god, I did switch. Whew. If I print that out, we print out the object name is Emily, score is 99, rank is 1. Makes sense. I can print out individual elements. So I can print out just the name. Dictionaries and objects are probably the most used and powerful and important component of the language. In many ways, the Python language is built around these objects. I can reassign specific elements of the dictionary. So for example, I've changed Emily's height here to be 159. So dictionaries are like structs, but way more flexible because again, I can then I can make it 159 centimeters. Now, okay, I've now changed the type of that value. The other amazing thing about dictionaries in Python that is will often trip a lot of people up is that here, the keys don't actually have to be strings. This can be an integer called 4. Now, what that means is I changed name, so this will no longer work, right? Because there is no key called name, but I can give the key as 4, and it works. So that's an odd thing. The keys are in structs, all the keys are strings, right? In Python, the keys can be anything. This could be an array. Isn't that weird? You would never, ever, ever do that. In fact, I don't know does that work like that? No, okay, it can't. It's got to be hashable. Okay, that makes sense. So you can't do that. Oh, could you? No, you can't do that. Okay, so it has to be like a immutable type, I think. So it could probably be like 1.1. Yeah. This isn't hashing as in like, yeah. This feels illegal. Yeah, it does. Python often feels like this. You can use tuples. Okay, that's a great point, Hamish. That's an excellent point. Why can we use tuples? I'm going to take your word. Why can we use tuples but not arrays? Because they're much more, whoops, if we go like that, they're immutable. Okay, tuples are immutable. They are like strings and integers in Python. And so that means we can use them as keys. Why would you do that? No. Why would you do that though? Yeah, I would almost never do this. This is crazy. But you can imagine that I might want my key to be an ID, and I might want that ID to be an integer. Because maybe I want to somehow dynamically calculate what my IDs should be, or something like that. So there are some reasons why you would do this. I can imagine some cases where you might do something like this. It might save you some extra steps. But yeah, I wouldn't see this very often. It's a tuple. That's how I call it, at least. Okay, yeah. I hope you're starting, you're getting the theme here of how sort of dynamic this language is. Okay. I'm spending so much time on this. Combining, this is sort of just a bit of everything thrown together. I'm going to leave this one for you guys to look at. I'm not going to talk about Python 2.3. That discussion's been had to death. We're using Python 3.7. I've already discussed why we're using that. And here's the feedback QR code. Please quickly scan it. We don't have much time. And just to sort of, not that I need to, but just because I wanted to prove to everyone that I really care. Yesterday, there was some feedback. I think it was anonymous feedback that they found the chat distracting, right, on the code and on the, sorry, I just realized my mic might have been a bit too loud and it was cutting out. That they found the live chat on the stream a bit distracting, so I've removed it. So you could say I am really trying to listen to the feedback. So please, quickly, you all know how to use a QR code. 5, 4, 3, 2, 1. Okay, let's move on to the next part of the lecture really quickly. What does it mean that we can have higher versions of Python installed? So you can have multiple versions of Python installed, and you can give the version of the Python in the, it's quite soft. Okay, I'll just put it back. I'll just put it back to what it was. You can have multiple versions of Python installed. In the future, we're going to talk about how you can manage multiple versions. If you've got Python 3.7 installed and Python 3.8, Python 3.7 will run the Python 3.7 version. All right. How many of you use the slides link that I am posting? What have I done? In fact, actually, I think I'll just click that, drag that here. No, I just want to open it. I just want to, what have I done? Give me a sec. Oh, no one's using it. Some people do. That's okay. Okay, present here. Open the speaker view. Okay, that goes here. That goes like this. All right. Yeah, it's okay that you don't have time to read it. That's okay. That's okay. It's just, you can follow along. I don't know if you can keep access to it later. Okay, we have less than 30 minutes left, but that's okay. This is just an extension of some of the stuff we're doing in Python. One of the really powerful things about Python is something called Pytest. It is a program that we can use that can automatically run unit tests on our Python code. It's a way that we can define some tests to make sure that our functions are implemented correctly, and that as our functions evolve over time, that they don't devolve and run into bugs that we haven't thought about when we made some specific changes. So let's do a really quick Pytest example, okay? Let's just copy this. Let's come here, go to code, delete that out. Let's reset that. Okay. Here I have a function. I'm going to actually cut this. Here I have a function called getEvens. It's going to return none for now. Yep, you can see this all okay. Okay, it's going to return nothing. If I run getEvens and I give it the number 4, let's comment that out. Oops. Nothing happens. Obviously, I'm calling the function getEvens, passing it the number 4, and it's returning none. Okay. I have not implemented getEvens yet. Okay. So I'm a programmer. I'm working on this project. I am being tasked. I've been given a Jira ticket to create this function getEvens. Now, in fact, that shouldn't be like that. That's actually a list of numbers. Something like that. What I want this function to do is return to me a list of all the values in the list that were even. So this would return 2 and then 4. If I put a 5 here, it would still just return a list with 2 and then 4. Okay? That's what I want the function to do. I don't know how to do this yet. It's my first day on the job at my internship that you're going to be getting in some couple of years or something like that. I don't know how to do this yet. I do know that if I call this magical getEvens function, I want 2 and 4 to come out. How do I describe that? We use assert. Assert is part of the Python language. What am I asserting? I'm asserting that if I call getEvens with the list of 1, 2, and 3, it should be equal to a list of 2. Now, keep in mind, this is my font ligature. I should turn that off for this lecture, so I apologize about that. This is a double equal sign. It should return a list that just contains the number 2. Okay? All right, but I have not run this. I have not written this code yet. So is it going to return a list with the value 2? No. But I can still run Pytest. And I see here that... Oh, okay. I've jumped ahead of myself a bit too far. In fact, actually... Yeah, you can see here. So it's part of the Python language, actually. So if I just run that program, it defines the function, doesn't do anything. This is not doing anything, I was just describing. It calls getEven with these 3 values, and it tries to check that it's equal to this list of 2, and it's not able to. There's an error because it doesn't assert. It's not the same. So I can write a bunch of my tests in advance. This is called test-driven development. And it's breaking because the first one holds. What I can then do is create a function here called test getEvens that contains these asserts. Okay? Now what I can do is actually run Pytest. Now if I just see if I'm in a directory with the program.py file, if I just run Pytest, it will try and run the tests on any file in this program. Why did that collect nothing? No tests ran. Let me look at the slides again. Oh, I know why. Okay, I've made a mistake again. Oops, I shouldn't have made that bigger. Okay. Okay. Let's clear this out for a second. What I can also do, what I need to do first is write a test program.py file. And in this file, I can write, let's just put this back and then comment it out. I can define all my test functions that will test this get evens. In fact, just to make this simpler, I think if I put this up here, okay, let me try this. Okay, that's what I wanted. Now, I think this is going to look a little bit better. How does that look? Oh, God. Okay. I think that might be a little bit clearer. So, what's happening here? So, if I run Pytest in the terminal, it looks in your directory for any file that contains the word test in it, or that starts or ends with the word test. And it then runs Pytest on that program. Pytest then interprets that Python code, looking for any functions that have the word test in it, and then it runs the assertions, and it can tell you which of those assertions passed or failed. In this case, it's stopping at the first one that fails because it doesn't bother continuing because it can already assume that your function is not implemented correctly. But what's interesting here is that I've defined my tests before I defined my code. So what this means, and if you do this test-driven development, it's a really good habit that we don't do enough. If I sat down and I said, okay, if I thought about all the edge cases, well, what happens if, you know, I've only got one element in my array? Well, it should return that element. Well, what happens if I have no elements in my array? That's a good question. What should happen if I have no elements in my array? I've got to think about that. In fact, it looks like we haven't actually thought about that. Or maybe it should just return an empty list. I mean, that's reasonable. But we've got to make that decision. We've got to decide with the rest of our team what this function's contract looks like. I define all my tests. Remember, test-driven development. The tests comes first. When you work on your project, you need to be doing test-driven development. We will actually look at your project work and determine that you wrote your tests before you wrote your code. Okay, now let's actually start looking at this. Let's do something a bit weird. Let's do something a bit tricky. What if I just return a list with the element 2 in it? Will this test pass? Will this function, getEvens, return a list with the element 2? Think about that for a second. Yeah, the function will return. I've told the function, hey, I want you to return the list 2. So will this test pass? Absolutely, it should pass. Let's try that. Let me clear the terminal and run it again. Okay, this is pretty cool. What this is saying is that this, where is this line coming from actually? Did I have... Where's that line coming from? Oh, I have to put them in separate functions? No, I thought you can have... I thought you could. Yeah, no, I think this is working okay. Yeah, what this is saying is it's running this test here and it's getting an assertion error. You know, it's getting back a list with the number 2 in it, and it's not equaling an empty list because it's not returning an empty list. So you can see here that the first 2 assertions, they passed, right? If I wanted to get like the green output, yes, they would need to be in separate functions, but I can absolutely have a single function with a bunch of asserts. That's not the problem here. I was just confused in how it was telling me to read this. The test that's failing is this one here, this line here. And that makes total sense. This function, this assert, is testing that the result is a list with the number 2, which it is, so that was no problem. But so is this second test. What starts to fail is because the test doesn't return an empty list. Okay. Similarly, if we got rid of this assertion, is this assertion going to pass or is it going to fail? It's going to get stuck at that assertion because it's not going to be able to pass that assertion because the list is always just returning an element with a list with the element 2 in it only. The reason that this is interesting is because you can see that with your collection of tests, you can sometimes write a function that happens to work for some basic situations. But if you go and you expand your test cases, then you'll see, okay, this function's not actually doing what I need it to do. Now let's implement how the function should actually work. So I'm making a new list called evens with an empty list. I'm iterating over all the values in the list nums. So it could be 1, then 2, then 3, or just 2. If the number, so this is very much like, something like you could do in C. If that number is divisible by 2 with no remainders, that means it's it means it's an even value. And if it's an even value, we append it to the list. Now, what will happen if no values meet this case? Well, then evens is just an empty list. At the end, we then return evens. So what happens now if I run my tests and I'm assuming that all these tests should pass? I run Pytest and we can see here that 100% of our test functions passed. That means that this test function passed, all these asserts passed, and I'm comfortable that my function's doing what it's meant to do. This is the power of Pytest. It also means that in, let's say, 6 months, okay, I graduate, I finish my internship, Hamish Cox comes along, he replaces me as intern number 2, and he's told, Hamish is told, hey, Hamish, this get evens function, we don't want to be using, what am I trying to say here? We want you to change the function to have some comments because it's not commented yet. So Hamish comes along and goes, okay, I got to add some comments here. Okay, evens needs to be an empty list at the start. Some crappy little comments. Not that Hamish is crappy. Hamish is very good, I'm sure. But then he comes along and he accidentally, I'm trying to think of like what's it, like an actual thing that could make a bit of sense. Maybe Hamish does this. Okay. Maybe Hamish accidentally tabs over this returns. He adds his comments and Hamish thinks, okay, awesome. First day done. I'm going to get a pay rise. Look how good I was. Didn't realize he made that mistake. Hamish pushes his code to GitLab and GitLab automatically runs Pytest. This is what we do to mark your GitLab repos. We run Pytest. We know what your code should produce. The GitLab runner automatically runs Pytest and it goes, hold on, Hamish. You cannot publish this code. Mate, it's broken. Why is it? I don't know why you broke it, but you broke it. Flashing lights come on, emails get sent. Hamish's manager storms, kicks the door down. Hamish, what are you doing? Hamish looks and goes, oh my God, I'm so sorry. I accidentally, my cat was on my keyboard and hit tab and broke it. Okay, we fix it. We run Pytest. The tests pass. In real workplaces, they just let you break production. That happens. These are software engineering practices to try and get us so that we don't break production. Yes, this example is not realistic, Richard. Although, you know what? Why not? I mean, I've seen mistakes like this happen. Most of the time, you're making logical changes to the code and you've not realized that you broke something. But this was just to demonstrate an example of how powerful Pytest is. If you automatically run Pytest on your code and you've got good tests written, then you will catch a lot of errors. I'm pretty comfortable leaving that stuff there. So let me give you another sort of anecdote. Well, not really an anecdote, but Actually, you know what I can do that's even better? Yeah, I just picked on Hamish for no reason. So this is the code base for the formative system that you'll all be using at some point in this course. Now, this is not a Python code base. This is a Ruby code base. But all sort of languages like this have things like testing frameworks like this. I don't know why it's so slow to load these files. But here you can see all the tests written that we have written for this project that automatically gets run anytime someone pushes a change to the project. I assert that my user is who I think it is. I assert that my users have the correct authentication roles. I can assert that if I do a certain thing that shouldn't work, I get a 404 back and that I don't actually get any data back. And I want you to look at all the test files in this project. Now, by no means is this project a gold standard of how a project should be tested. This is an open source project. We don't have a huge budget and things like that. I can only imagine what even larger projects look like. But look at this file alone. This is all just tests. None of this code contributes to the functionality of the project itself. But tests are so important because, there's 1,200 lines of tests here. You make changes to some small part of your code and that cascades and affects some other remote system that you didn't think about. If you've got good tests written, you will catch a lot of issues and save yourselves a lot of stress and a lot of headaches when you're writing production systems. Okay. I think we'll call the actual content of the lecture there. Yes, I will generate PDFs to these slides. All of the lecture code is available already in this repository. We have a few minutes, so let me catch up on the chat and let me go actually. Okay, something else worth talking about a little bit. Okay. Here we are. So remember I spoke about we write the tests before we write the functionality of the function? That's called black box testing. I don't care about how that function works or how it operates. All I know is what I want it to give me. So that means I can write my tests first. This is how we want the test-driven development to work for your project. Design by contract is sort of building on that example. Design by contract says that I know what my function should do and what it should return to me, and then I can build the implementation later, but I can define my tests now to make sure that I adhere to that contract. Systematic Python testing, that's what I was talking about in terms of I push my code to GitLab and it automatically, systematically runs Pytest for me. So that's a really important part of that. And I spoke a little bit about the Pytest structure. You must have a Python file called something underscore test or test underscore something. You need to have functions in that file called test underscore something and that contain a section of asserts. You do not need to have one assert per function, but you need to have one function with the asserts called test underscore something. Okay, there we go. The slides actually didn't contain anything we missed. There's the feedback QR code once more. We do still have a few minutes. I can answer questions and while people give their feedback. Okay. Whew. I need to make sure I bring more water when we do these. Okay. I don't know what Sam's saying. At Richard DePeters, Mr. Jake Renzella. That's Dr. Renzella to you. It's just the way that you said it was. Okay, I think you guys are having fun. Do we need comments to describe test files? That's a good question. I mean, you don't need them for them to run, of course. Yes, you should have comments to describe what your test is trying to test, only if the test line itself is not self-explanatory. In general, while we're here, one of my favorite books on software engineering is a really short, easy to read book called Clean Code. And this sort of describes my position on comments generally. Yes, you have to have comments in your code. You will have comments in your project. But some students grapple with what code you should comment and what code you shouldn't comment. And I think this book really captures what I think about the topic as well. Leave the testing to the testers. Developers get paid more. That's not true. Developers often write the unit tests. Testers might test a project end to end, but they're not writing the unit tests. Thank you, Daddy Jake, for the lecture. You're welcome. If we have multiple Python installations, do we need to specify the specific Python version for that Pytest? Ooh, good question. Pytest will likely just use the default version of Python. So you'll need to make sure that your Python is set up in that environment to be 3.7. We have a lecture and documentation around how that works. Should they be in the same folder? No, Steve. Oftentimes they're not. If you look back at my project here, all of our test files are in a directory called test, a separate directory to where, for example, the authentication file actually lives. The reason for that is so that we don't have just a lot of noisy files when we're working on our code base. We can sort of isolate them. The testing framework might need to be told how to find where all the tests live. So you might need to just give it, you run Ruby test or whatever it's called in this test directory so that it runs all these tests. Where do you access the manual for Python? I think you mean like the Python docs. Oops, I can't type. Docs.python.com, specify Python 3.7 here, and here is the manual, the API reference, the language reference for Python. Pen testing is good, red team rise up. Felix is on a crusade. The slides use import my math. I don't know what you mean by that, Steve. Sorry. Is there a standard library for Python? Absolutely. You must use Python 3.7, Starkiller. I thought you said you were going to change your name. There is a standard library. Library reference, here we go. Here it is. This is the standard library. You don't need to... Some stuff is given to us... Whoops. Let's close that. Some stuff is given to us automatically. We don't need to import anything at all. Some stuff, for example, so if I want to get, for example, program arguments, I need to import the system library. But I don't need to install that library. It is part of the Python standard library. I can actually run this really quickly, for example, if you're curious about how this works. Python 3, program.py. I'm going to give it an argument. Just call it Starkiller. Is that a Star Wars reference? Is that the guy from the game? Is that right? Why didn't that work? Oh, never mind. Program.py is the first argument. I can actually just run it with all the arguments. Here we go. argv is an array with all the arguments passed to my program. So, and to do that, we need to import the system library. On my local Ubuntu computer, the apt repository only gives me 3.8, 3.7, and 3.9. There will be a way to get 3.7 LR. I am 100% certain. You might want to look into, we have a lecture on this. You might want to look into something called PyEnv. PyEnv is a program that lets us specify the different versions of Python and install them. I use PyEnv personally. So for example, I can, no, there's no list. I forget what the command is to view all the versions of Python that are installed, but you can go like pyenv install 3.7, for example. Okay, you got to give a more explicit. Oops. So here's all the different versions of Python I can install. So I got to give it, say, 3.7.1. And that's going to go ahead and install, I'm not going to do it, but that's going to go ahead and install Python 3.7 in my environment, and then I'm able to switch to use that. Okay. Has everyone done the feedback form? Then I switch over to here. And guys, feel free to, that's the end of the lecture. Feel free to head off. If you want to stick around, you got nothing to do and you want to chat, I'm happy to do that for about 5 minutes. Richard asks, why do data scientists use Python? What a good question. It's a complicated question. There's a few answers to it, Richard. So for reference, again, I used to work at the Applied Artificial Intelligence Institute. So we were all data scientists, software engineers, working on industry-funded data science projects. So yeah, and if you're going, that's fine. So why do data scientists use Python? Reason number one is that the data science libraries for Python are the most advanced and the most capable. Something I use a lot is pandas. Let me show you actually. I don't know how many of you are sticking around. If you want me to keep talking, if you need to head off, just let me know and I can stop. But when you're working with very, very large data sets, you need data science specific libraries, and the ones written for Python are very good. Whoops. Pandas is an example. Pandas is a data analysis and a manipulation tool is what they call it, built on Python. It's a very rich, robust library. This really led the way in data science capabilities. So the first reason is that there are great data science libraries. The second reason is that data scientists aren't software engineers. They're not really concerned with writing, they're not always concerned with writing long-living, architecturally stable, well-designed, well-tested programs. What they're interested in is building models with as little friction as possible, that are as performant as possible using the tools that they have available. Oftentimes, many of our data scientists weren't classically trained software engineers like you guys are. And what that meant is that they get frustrated working with C or C++ or something like that, even though the language itself may be faster, but they need to really hook in and do a lot of data science work. They don't really want to do a lot of engineering or programming work necessarily. So a language like Python just suits itself better. A few of these little reasons like that add together, and then what happens is you get momentum. And once you have momentum, then it's really hard. So Python is now the data science language. The libraries, the attention is paid for Python for doing that. It's going to be very hard, even if a better alternative comes along. It has to be much better to claw people away from what they're comfortable using, which is Python. Hopefully that's a reasonable answer. So 3.7.x, that's fine, Steve. It doesn't have to be, we don't care about what happens after the 7. Thank you guys for coming. I have an unrelated question. My C extension is disabled in VS Code. It says because it doesn't support a virtual workspace. Well, you don't need the C extension in 1531, unless you mean you need it in general. So Richard, I would have thought performance would be a priority for data scientists. You're asking good questions. Performance is always a concern. So people say Python's not as performant as C. Python's not as performant as C. Python is very performant. You can take, if you take a good Python developer and they write well-designed Python, it will run faster than anything you or I can write in C. Unless you got, a real C expert that could really optimize it there. Python is not slow. Python is plenty fast. What data scientists concern themselves with, yes, the scale of what they're doing matters, but the performance in terms of how long does it take to write a model, they don't really care about. As long as it's somewhat reasonable. CPUs, like Steve says, CPUs and GPUs are plenty fast. They care about the performance. When I said the performance of the model, they mean the accuracy of the model. That's what they really care about. How accurate is my machine learning model? If it takes 5 seconds longer, even if it takes 2 hours longer to build that model in Python, they don't really care. They build it once. Comparing Python to C. They care about how accurate their model is, and do they have the tools to build that model as quickly as possible. Second point is that the libraries like pandas and stuff that you're using in Python, these likely are at some point running as native C libraries. So you're getting the performance there anyway. I don't know if you can use matplotlib on a CC machine, Justin, sorry. Okay, thank you all. I think that's a good place to call it. Thank you for sticking around if you did. Good luck in your tutorials and labs for the rest of the week, and keep an eye on announcements and things like that, and I'll see you next week. See you, everyone.